Hey everybody! Today we're going to spend some time looking at how the amount of energy an electron has affects its shape and kind of motion around a nucleus of an atom. So what I have here is a carbonless transfer paper, and what this does is when I drop something or hit it, like you can see, what happens is it will transfer an image onto this bullseye. So what we're representing here with this is an atom. So we have the nucleus of an atom, and we have each of these areas around an atom. Each area represents kind of higher and higher energy zone around the atom where electrons can occupy. And what we're going to do here to simulate electrons with energy is we're going to drop a marble, and we're going to try to aim right for the bullseye here, the nucleus. But as we drop the marble, we'll be able to see where the marble hits. And so here we're doing it from eye level, so this is going to be a higher energy than this one when we drop it from waist level. We're going to drop the marble from waist level. And I will record us doing that, but I wanted you to see that. So we will drop it, and at waist level that's going to be low energy, and we can kind of make a prediction about where the electrons are going to be, because low energy electrons, where would they be likely be? Are they going to be closer to the nucleus? Are they going to be spread out? And then as we add more energy to the electrons, are they going to be, gathered around the nucleus, or are they going to be more spread out? Okay, so why don't I set that up, and you get to see me drop a marble. We're going to drop it 100 times at the target. So I enlisted the help of my helper here. We're going to drop a marble 100 times. Okie doke, here we go. Okay, so that was 100 drops at waist level. And so now what we're going to do is we're going to give the electron more energy, and we're going to simulate that by dropping it from eye level. So thanks to my helper again. So, okay, here we go. Okay, so now what I have here is the results. This is the waist level one. This one is a yellow transfer paper. So what I'm going to do is I'm going to tabulate the results. I'm going to take every single one of these dots, and I'm going to create a little table up here, and I'm going to find out how many times it hit in zone 1, zone 2, zone 3, zone 4, zone 5. And zone 6 is anywhere outside of the paper. Okay. And then we're going to see how common it is. And remember, this is the lower energy electron at the waist level. Okay, so I tear this off, and I will start counting. And so here's one that I forgot for zone 2. There's one in there that is completely in zone 2. So that's 44. Okay, now zone 4. So let's just double check to see how much that is. Let's see. It's 8. That's 78, 87, 97. So that's 97. So that's good enough. Okay. So, oh, there is one way out here. Look, my hand, I was here. There is one of these way out here. So there is a 1 in zones. So that's 98. Okay. There's probably a couple that I missed, but we dropped it there. So, okay. So that's waste level. Now we'll do this. Now we'll do the same thing for the eye level one. So remember, the eye level, not only was it at eye level, but we were simulating even more energy by standing on top of that and the coffee table. Don't tell my wife, because she gets mad when we stand on the furniture. Again, if it overlaps, like this one is in both zone 1 and 2, I'm going to count it for 2. Okay. Okay, so let me add these up again and see how many we have. So that's 23, 43, 71, 82. So that's 102 that I counted up there. Okay, so there we go. This one I'm not counting because this was a bounce. Like, this ball bounced over here. So I purposely don't count the bounces. So what I'm going to do now is transfer this to this data to a table in Google Sheets to make it easier to see, so that when we answer questions, we get a better idea of what's going on. So I've titled this Marble Drop, and what I'm going to do is I'm going to transfer the data from that data sheet, from the pink and yellow data sheet, onto here. So we'll do waste level, and remember that this is the lower energy, make sure I spell energy right, lower energy electron. Okay, and then they were dropped, and then when they were dropped, they hit a certain zone. Zone 1 was the closest to the bullseye, and then 2 was the next, 3, 4, 5, and then 6 was anywhere outside of the target, whether it was on the paper or not. Okay, and then for the and then we'll plug that information in here. And then don't forget that there was an eye level, and those were the higher energy electrons. And again, we drop those and they hit a certain zone. Zone 1, 2, 3, 4, 5, 6. Okay, and so I'm going to enter that data in there. So I entered the data in there, and you'll notice that if we look at zone number 1, the area that contained the bullseye, the thing that was dropped from a lower level, there was more areas in the bullseye. Okay, and then as we got further away, there was less, and then there was hardly anything that didn't hit the target. Almost everything hit the target. And so what we can do is we can visualize this by making a graph. So let me do that. So this is a bar graph, and this bar graph is showing that the electron, when it's low energy, is going to be found in zones 1, 2, and 3. That's what it's saying. It's not going to be found very much in zones 4, 5, and 6. But let's compare that to a higher level or a higher energy electron. And let me bring up again a graph to help visualize the data. So now for the second graph, you'll see that yes, the chances of it being close to the bullseye have gone down, but notice that it's now spread out over more zones, to zone 2, 3, 4, 5, and 6. So what this does is it simulates how an electron moves. If it has low energy, the chances of you finding it closest to the nucleus are pretty good. If it has higher energy, yeah, you can find it close to the nucleus, but notice that the zones that it's going to occupy are going to be spread out. They're going to be found in a lot of the zones. And this is exactly what an electron does. A low energy electron is going to be found close to the nucleus. It's going to be found close to the bullseye. It's not hardly ever going to be found out away from the nucleus. A high energy electron isn't ever going to be found close to the nucleus. It's going to be moving around in such a way that it's going to be spread out and found, just as likely found far away from the nucleus as it is kind of close to the nucleus. So you can see here that high energy electrons definitely need more space to move around an atom, as opposed to lower energy electrons that don't need as much space. So what I'm going to do is I'm going to give you a couple of questions, and so make sure that you find the questions so that you can interpret this data with me, so that I know that you know what's going on. Okay? Have a great day, everybody.